Hi, my name is Krithi and today I'll be explaining how the production of magnetite nanocrystals in a kitchen environment can provide a sustainable alternative to the established laboratory synthesis. Over the summer, Business Insider stated that water bottles from multiple stores were contaminated with high levels of arsenic. Fortunately, many studies have proven that the effect of magnetite nanocrystals on arsenic adsorption and uptake in water is astounding. The synthesis of these nanocrystals is often expensive and complicated. This project aims to efficiently synthesize magnetite nanocrystals by utilizing common household materials. In the United States, arsenic in drinking water is a minor problem. However, in many developing countries, bottled water is a luxury. Inorganic arsenic is lethal when consumed in excess, especially in countries like Bangladesh, where contaminated water is used for everything. Bangladesh's polluted well water is considered one of the largest public health crises in the world, and yet remains relatively unknown outside of scientific circles. According to many research papers, magnetite nanocrystals can be synthesized in a laboratory environment by combining iron oxyhydrates and oleic acid through thermal decomposition and refluxing. This can be mimicked through saponification and acidification, detailed in the research paper and equations shown here. 3 oils will be used to test for the most efficient production: olive, soybean, and corn oil. If different types of oils are used in the synthesization, then olive oil will work best in order to produce magnetite nanocrystals. The procedure is separated into 4 different parts: saponification, production, synthesis, and separation. A more intensive procedure can be found in the research paper. The end product, the magnetite nanocrystals, are shown here. The results show that all oils produce successful results, with olive oil being the most effective and soybean the least. An interesting correlation between the amount of nanocrystals in the black slurry and amount of organic fat layer was also observed. Although corn oil produced less black slurry than olive, almost 42% was made up of nanocrystals. This is most likely because corn oil had a greater amount of organic fat layer. Through transmission electron microscopy, it is also possible to examine the size of the nanocrystals. Studies have shown that finer crystals work better at removing arsenic from water. Since many oils contain 4 dominant fatty acids, these can be tested as controls. The results could be used to efficiently develop and test the effect of magnetite nanoparticles on arsenic adsorption, uptake, in water. I sincerely hope that the findings of this study can be used to provide a sustainable future for us all. A huge thanks to my parents and teachers for guiding me through this process, and of course the judges for taking the time to thoroughly review my project.